Day 4, Problem 1. Shayla is enlarging a digital photograph on her computer. The original photo is 5 inches by 7 inches. If she enlarges the dimensions 1.5 times, what will be the perimeter and area of the new image? So in this question, it sounds like we have a photograph that is shaped like a rectangle. And so here is a quick sketch of this original photograph. And we are told that it is 5 inches wide and 7 inches high. So this dimension is 5 inches. And then vertically, this dimension is 7 inches. And what happens is she's going to enlarge this photograph by multiplying each of these dimensions by the scale factor 1.5, and that's going to result in a larger photograph. So this isn't to scale, but a larger rectangle might look something like this. And what would be the width and the height of this new larger photograph? Well, we're told that the original width is 5 inches and that she's going to multiply that by 1.5 times. So 5 inches times 1.5 would create a new width that is, let's see, 1.5 times 5. 5 times 5 is 25. And 1 times 5 is 5, plus the 2 that was carried is 7, and there is 1 digit to the right of the dot, and so the decimal point goes here. That is 7.5. So the new width of the photograph is 7.5 inches. Now, what is the new height of the photograph? The original was 7 inches. And again, it's going to get multiplied by a scale factor of 1.5. So the height would be 7 times 1.5. What does that make? So how about a little scrap work again? 1.5 times 7. Let's figure out what this is. 5 times 7 is 35. Carry the 3. And 1 times 7 is 7, plus the 3 is 10. And once again, there was one number to the right of the decimal point. So in the answer, let's put the dot right here. So there's one number to the right of the decimal point, and that is 10.5. So the height of the new photograph is 10.5 inches. Well, we know the width and the height of this new larger photograph, and we are asked essentially to figure out two things about it. First, what is its perimeter? And second, what is its area? So perimeter, what is the distance around all the edges of this rectangular photograph? So let's find that. Perimeter. It is 7.5 inches across the bottom, plus it is 10.5 inches high, plus it is 7.5 inches across the top, plus, and it is 10.5 inches down the side. So adding these all up, we will have the perimeter. So maybe a little grouping. 7.5 plus 7.5 is 15. And the 10.5 plus the 10.5 is 21. And 15 plus 21 is 36 inches. That is the perimeter of that photograph. The other question we were asked is, what is its area? So let's tackle that. Now, to find the area of any rectangular shape, we can multiply its width by its length, or in this case its height, and that will get us the area. So its width is 7.5, and we want to multiply by the height of 10.5. So 7.5 times 10.5, what does that make? Well, let's grab a piece of scrap paper and figure that out. We have 10.5. We'd like to multiply by 7.5 and see what that makes. So 5 times 5 is 25. Carry a 2. 0 times 5 is 0, plus the 2 is 2. And 1 times 5 is 5. I'm going to start my next row with a 0. 7 times 5 is 35. Carry the 3. 7 times 0 is 0, plus 3 is 3. And 7 times 1 is 7. Adding these two results together, 5 plus 0 is 5. 2 plus 5 is 7. 5 plus 3 is 8. And here is the 7. There is 2 numbers in total to the right of the decimal points. And so in the answer, if I put the decimal point here, I will have 2 numbers to the right of that decimal point. So 78.75. So back to our warm-up. Multiplying these together, it created 78.75 square inches. There are 78.75 square inches of space within that rectangle. Now, day 4, problem 2. A cylinder has radius 5 centimeters and height 8.3 centimeters. Part A, sketch a picture. So we need a picture of a cylinder. So let's see, a cylinder. A cylinder, to make it look three-dimensional, maybe an oval to be the top, and some lines coming downward to be the sides of the cylinder, and the bottom of the cylinder, kind of round this off a little bit. And sometimes we even take the time to do a little dotted line to kind of show that back hidden edge of the bottom. That's sort of an unnecessary thing, but it might help create the illusion that that cylinder goes around. Okay, now to label. The radius is 5 centimeters, so the distance from the center of that top, which is a circle, to the edge of the cylinder, that is 5 centimeters. And we're also told that the height is 8.3 centimeters. So from the bottom of the cylinder to the top of the cylinder, that distance is 8.3 centimeters. Okay, there is our sketch. Now part B. Use the formula V equals pi times r squared times h to find its volume. We are asked to find the volume of this cylinder. How much space is contained within that three-dimensional object called a cylinder? And we're given the formula that we can use to do that. The letter V represents volume. That's what we're asked to figure out. And we can find the volume by taking pi. Now, as a decimal, pi can be rounded off to 3.14. And the letter R represents radius. That was a number that we know in this drawing. It's 5. And the letter H, the height, we know that as well, 8.3. So this problem can be done by starting with that math formula. V equals pi times radius squared times height, and then substituting known values from the drawing. So I'm going to draw a line downwards from the equal sign. Again, that helps me keep the left side of the equation separate from the right side. And fill in numbers that I know for these different symbols. So for the symbol pi, 3.14 is a number that can be used for pi. For r, the radius, that is 5 centimeters. So 5 gets filled in for r. And that is squared in that formula. And then here on the end, it says times h, times the height. that is 8.3. So here on the end, 8.3. And to find the letter V, it looks like that we really just need to multiply all these numbers out and see what it makes. So V equals. First thing I'm going to do is address this exponent. 5 to the second power, that is 25. So we have 3.14 times 25 times 8.3. Okay. And then V equals 3 numbers that we need to multiply together. It doesn't matter in what order we multiply them. We're just going to have to do a little bit of scrap work and we can get the answer to this. So how about starting with 3.14 times 25? What does that make? So I'm going to grab a piece of scrap paper and we're going to figure out 3.14 times 25. 3.14 times 25. 4 times 5 is 20. Carry the 2. 1 times 5 is 5, plus 2 is 7. And 3 times 5 is 15. And start the next row with a 0. 2 times 4 is 8. 2 times 1 is 2. And 2 times 3 is 6. And then add these two rows together. 0 plus 0 is 0. 7 and 8 is 15. Carry 1. 5 and 2 is 7. Plus the 1 is 8. And 1 plus 6 is 7. In the original problem, there are 2 digits to the right of that decimal point. And so in my answer, if I put the decimal point here, I will have 2 digits to the right of that decimal point. That is 78.50. Okay. Now, if you recall, there is another number that we needed to multiply to that, and that is 8.3. And so let's take our 78.50, though that's unnecessary to put that, and multiply by 8.3. So 5 times 3 is 15, carry the 1. 8 times 3 is 24, plus 1 is 25, carry the 2. 7 times 3 is 21, and plus the 2 is 23. Start the next row with a 0. 8 times 5 is 40. Carry the 4. 8 times 8 is 64, plus 4 is 68. Carry the 6. And 8 times 7 is 56, plus the 6 is 62. And then add these two rows together. 5 and 0 is 5. 5 and 0 is 5. 3 and 8 is 11. Carry the 1. 2 and 2 is 4. Plus 1 is 5. And bring down the 6. Now in the original math problem, there is 1 number to the right of the decimal. Here's another number to the right of the decimal. So there are in total 2 numbers to the right of the decimal. So if we put the decimal point right here, there are 2 numbers to the right of that decimal. And that result is 651.55. So going back to the warm-up, when multiplying all 3 numbers together, we figured out it was 651.55. And we were asked to find the volume, and so we have discovered that the volume is 651.55 cubic centimeters. That is how much space is inside that 3-dimensional object called a cylinder.